Michael Walker. I am a new graduate student here at Vanderbilt University. My research focus has been on more of the security at the operating system level. And I'm just going to give you a brief introduction to basic design philosophy and how to get started with Android programming if you're interested, and knowing a little bit about how the system works underneath, because that's really the core facet of understanding Android security. Encryption and things like that, you just use what they give you, basically, most of the time. But the understanding how to make a good application is really, it's kind of a different design philosophy than it is on a desktop or something along those lines, because first of all, you're running in a virtual machine and on an embedded device. So you have to take all those things into account. So that's actually my undergraduate's mascot. We're the only school that's a penguin, so I thought that would be appropriate for a convention like this. Pete, by the way. I went to Youngstown State University. If any of you are college football fans, you will know where that is, sort of. Or at least who used to coach there, Jim Tressor. So, OSU. I have gone to what's called RUs, kind of a research experience for undergraduates. The National Science Foundation actually sponsors them. When you're an undergraduate, you can go and do research at different universities. So I went and did research at UC Berkeley for a summer, and then here at Vanderbilt, actually, and probably helped a lot in getting in. 389, 4 Bs. But now I'm going here to Vanderbilt for my doctorate in computer science. Here's a general outline. Why is it? Like, why did they make it? Why did they design it this way, or what was their goal in making it? So a lot of these things you can just look up on the wiki or the website for Android, but in case you haven't looked it up or seen it yet, I'll go over it carefully. What is it? I'll go through some of the layers and aspects, I should say, of the platform of Android. Because Android's more than just an operating system, it's an entire platform of, it's an entire stack of things that I'll go over. How efficient is it? That's been where my research has been in, is measuring how fast it can do encryption, things like that. How good is native code written for the device versus Android code? And you'd be surprised. And then how to start programming for it, and then some Q&A. Okay, why is it? So Google and a bunch of other companies, I think it was like, mainly the first ones were AT&T and HTC. Those three got together and they got a big consortium called the Open Handset Alliance. I think it was like somewhere around 80 to 100 companies all got together and thought up, brainstormed what they wanted in a mobile operating system. So they did this because they wanted a standard platform for development, which we now know, Android. They wanted reusability, so you write a single piece of code, now called apps, for over here, and they work across multiple devices. So that way, little side project device over here can use all the work that's been done for all these major devices. It helps with, especially helps with the lower end phones, so they don't have to put in a lot of development costs for those free phones or the pay-as-you-go type of phones. They want to be able to customize the phones. So this phone has a camera on the front, this phone has a camera on the back, this has this has that. And because the way Android's designed, you can easily do that and have those features. And the way the Android market is, if your phone doesn't support the features that the application needs, your phone won't be able to see them. So it helps filter out and allow things to properly install and work when you can make use of them. Freedom, that's why I was asking you earlier, just as my own curiosity, who liked Android for the philosophy of it, and who just liked the phones. Personally, I really like the phones, and I really love the philosophy. Yes, it is open source. I don't care what you read online, except version 3, but that's entirely besides the point. Google does make contributions to Linux kernel and things like that, and it was easy to find before kernel level went down. Now it's back up for whatever. That's inside. And actually be useful. So applications on your old Nokia, not that great. Now on your new Android device, much better applications. What is it? First of all, it's Linux. It's generally they're ARM devices. I think now there's some Atom laptops and PowerPC version. I don't know if there's any devices that run it, but I know there's a version of it. There's x86 and different architectures, but it's mainly ARM devices running Linux as their core operating system. It's mainly the same Linux as you would get in most distros, sort of. It's one of those, it's this, sort of, ... It has a bunch of kernel mods added and a bunch of kernel mods taken out. So that's why I get that. Here's the important thing. When you think Android, you're actually thinking Dalvik. The Dalvik virtual machine is what makes Android Android. That is what sits on top of Linux and does everything that you think of when you're thinking Android. So applications, services, content providers, and other things that we'll get into. Content providers, I was saying. So the basic database methodology is SQLite. I'm not sure if you're familiar with that, but it's a really, really fast, small, lightweight database built off of SQL. Intense. That's kind of a URIs and content providers. They kind of all work together. They're kind of a complex system of intents are these bundles of information that you send to the operating system. The operating system does something with them. It's explained, but it goes through a bunch of filters basically, and where your how you formed your intent goes to the application or applications that can handle that intent. So when you say, I want to send a text message, it brings up a list to the user. Here's all the applications that can send text messages. You as the user decide, I want Google Voice, or I want Messenger, or I want ABCD Messenger 1, or whatever. So that's what intents do. They allow you to actually select at runtime what application does what functionality. URIs are a superset of URLs. So everybody's familiar with what a URL is. URIs just point to, I shouldn't say point, but they're more complex. They're similar to URLs. They're almost the same format written out, but they have deeper meanings. And there's lots of other little things that Android has going on underneath the, excuse me, underneath the hood, basically. And then finally, apps. So those are the things you install off the market, or you sideload, or you write yourself, or whatever. Dalvik. This is Dalvik in Iceland. It's the little city that Dalvik's named after. I just thought it was kind of interesting. The guy who wrote it, I think he wrote it on his 25% time for Google. And Dalvik's kind of interesting because it takes Java bytecode, recompiles it with a program called DX, and then converts it to Dalvik bytecode. And that sounds kind of odd, but there's a really good reason for that. Java has a stack, doesn't have registers. Java has a stack, doesn't have registers. Dalvik has registers, so it's more in line with how most of our programming in like C or Pascal or all of those C++ work. So they have registers, so it's more straightforward. You understand if you're familiar with how to do, how to handle caching with development on the desktop, you have a similar idea of how it works on the .NET. So that is important, but we'll get there. This is really key, this picture here. This is from Google's website. You can find it everywhere, basically everywhere, just copied it. Here's the 4 basic layers. You have your Linux kernel, and it has a bunch of your driver, low-level stuff, so firmware drivers, things like that, all work down here. So Wi-Fi, camera, audio drivers, things like that. Then libraries. This green thing is in here, and the yellow, which is the actual Dalvik virtual machine. Those are all written in C. So those are customized for whatever hardware architecture you're working for. So mostly, like I said, ARM. But over here, the core libraries and the Dalvik virtual machine, they're in their own little separate area there because everything above goes through those. So it's sort of a filter down and then gets through here. So the Dalvik and the core libraries work as an intermediary between your system, what you see and use, and the hardware and how everything actually works. And then you have your application framework. This is what makes Android work the way Android works. So this handles your content providers, your view system. So the view system's the actual screens, things like that, telephony, package manager, things like that. And the very top, your applications. So now that you have an idea of how Android's built up, there's some key things to understand about Android. Every instance of Dalvik runs in its own Linux thread. So everything's sandboxed. That's really important to Google's operating system, Android, is that everything's sandboxed and nothing can talk to anything else unless you give it permission. You either give it permission at runtime, so you decide, I want this program to handle this request. So like I said, I want to send a text message that has this information already bundled in this little bundle of information. I think they're called bundles, actually. Yeah, they are. Microsoft copied them and called them something else, but there's a shocker. So you send this little bundle of information out to the system and say, here's stuff, whatever. Text messaging programs can handle it. So you as the user select which text messaging program you want. That is one way of sandboxing. So you have over here's a nice little sandbox, and over here, and then Android and Linux handle how to get from here to here. You don't have to deal with that. The other one is when you install. So when you install an application, it says, do you want to give this application permissions to go to the internet completely, write to the SD card, read from the SD card, things like that. If you don't want to give it permissions, you can't install it. There's no official way to revoke privileges. There are some unofficial applications that you can block internet requests and stop writing to the SD card from applications and things like that. But we'll get there. Intents, that's what I was saying, the IPC, interprocess process communication. So the intents are what allow you to talk back and forth between programs. And that's really key because all Android applications that interact with each other use intents. And that's really the key philosophy of Android, is you have these, I'll call them modules for lack of a better term. They're called activities, but it's not really makes much sense. The namings aren't great, I'll do that. But they're these little modules that do something. So the module that looks at the your contacts. So that contacts, you have the screen of all your contacts listed in a row. Then you have, when you press and hold, you can open the contact. Well, that brings a different program, sort of, on top of your current program. They're called activities, but you can sort of think of them as mini programs that brings on top of and uses the information from what you selected. But the way Android is designed is you can have all these different sandboxes and communications going back and forth. You can write your application to say, here's my list of contacts. I'm not going to implement how you view a contact. I'm going to require that the system has a view a contact capability. And all I'm going to do is call that. So your program has used features that you don't even know about, which leads to, if you do other system design, makes sense. But this is the way Android decided to do it. So you can use the contacts as a bad example. SMS makes sense. So you send an SMS from this contact, you want to send a text message from John Smith to Mary, or you're Mary, and you want to send one to John Smith. You click John Smith, it brings up a dialog. Which text messaging program do you want? If you only have one, it just auto-loads it. But if you have multiple, you can get to choose as the user. Now, you only have one, it opens it up, or when you choose one, it opens it up on top of, sort of, your previous activity, and you can do what you want. And when that activity goes away, you can go back to the previous activity. So you can have a stack of applications. Originally, I think it was 6. Yeah, 6. You could have 6 applications running at once. And you can just, when you finish this one, you can go to the next one back. Or you could go to the home, or you could go wherever you want it. You have a shortcut to it. Content providers, that's another key concept that Google initiated and now others are copying. First of all, Windows 8, I believe, has them. They call them something else because that's what Microsoft does. But they are content providers. They're basically just wrappers around an SQL database. They have an API that you can make specific queries for. So you can say, give me all the contacts, or give me a list of all my MP3 files, or give me a list of all my movies. And the little database does that. The database itself generally doesn't store the big media files. It just stores URIs that point to the media file on the hard disk or hard disk. But that's generally what the idea of content providers are. They provide you content. Hence the name, obviously. But yeah, that's kind of a key concept. So if you want to store data, you probably want to do it in a content provider. And there's tons of them on the system. If you actually end up doing development, you can look in the virtual machine. You can see just a giant list of content providers. The nice thing is, those only run when they're needed. So when you request information, it starts up the content provider, gets the information, shuts down the content provider. So you don't have this constant bunch of services running, providing you every possible query you could potentially ask. It only loads them when you need, because, again, dealing with embedded devices. Covered this already. Register versus stack. That's one of the key differences between DOLVEC and Java Virtual Machine. There's some others, but that's the main one. And there's some key things you have to keep in mind when you're developing for Android devices. Except for the laptops that now have Android, you're all dealing with embedded devices. So there's power constraints, there's speed constraints, RAM, cache, everything is limited. So Google's original designers put in this real-time limit of 5 seconds. If your program runs for more than 5 seconds, you're killed. The only exception to that is threads. which means you plan to run for more than 5 seconds. Excuse me.
So when you get an error message that such and such app is stopped running, that basically means it's gone continuously for 5 seconds.
Correct. You can if you think the application is still running, but it's taking a long time, you can hit wait, and then it'll wait another 5 seconds. And then if it doesn't respond to user events, then pops up the screen again. But most users just automatically instantly kill. They did some user studies, and I think it was like 86% or something like that. And security. Yeah, obviously, never write your own encryption unless you are a math person, like PhD or computer science PhD, and you're writing a library or something like that. That's just no. But security in general for Android is there's some little caveats here and there. You'll want to look for how to provide good security for your device or for your application. And whatever application you're going to be making changes what you need. So internet, you're going to want to use the SSL capabilities to send encrypted information. So, or if you're going to do local encryption, you can use AES, which they just use the standard. I can't think of the name of it right now, but they just use a standard library that's out there for Java. They cut out everything that's not AES, RSA, DSA, and DES just for backwards compatibility, so you can read stuff that's encrypted with that, triple DES, whatever. And they just throw all the rest of those out. So if you like 2fish or Blowfish or RC4 or any of these others, they're not provided by the standard Android API. But you can use Java libraries. I think almost every Java library is importable. I don't know of any type of functionality that isn't supported through a type of library that's already out there. So the other thing is you're on an embedded device that might get stolen. So you don't want to store plain text, anything, if possible. So unless you just don't care. If it's a high score, I don't care. But if it's a password you're saving or caching, you're going to have to use the built-in encryption, either however hard. So there's much different levels. You can decide on what is the appropriate level. These are just things you have to keep in mind. And there's no good, I can't answer, you can't just say, you should use this, because you don't want to go overboard and just use the highest level security for everything, because then it could take extra time. Maybe you're concerned about performance, you're running a game. I mean, you have to make balances because you're on an embedded device. So you have to make trade-offs. We're going to go ahead and get to the Android programming. There's an SDK for all three of these, Linux, Windows, and Mac. I've used Windows and Linux. Windows 1 works really well, actually. So if you have to use a Windows machine at home or at work or whatever, you can do it, and it works really well. So don't fret about that. Mac is supposed to work really well. I don't have one, so I don't use it. But Linux works really well too. So honestly, the only two things you need are a JDK, either the Sun JDK or Oracle JDK, or the Open JDK. The Open JDK works fine for everything, except if you're going to be recompiling the basic applications that already come on those phones. So contacts, I think what else? The SMS app, things like that. They require code that's only available in the Oracle JDK. So that's pretty much the only difference between the two. The rest of them you can pretty much get away with. You might run into a problem with the library you're running, might require the official JDK. Other than that, you should be fine. And the Android SDK. The Android SDK comes in from the Android website. It's just a zip file. I don't think. Yeah, it's just a zip file. You install it into whatever directory you want, and then you have to add it to your path. It's a bunch of different little things like that, but not hard at all. And then technically, you don't need Eclipse. But if you're just starting out, I would highly recommend it because Android has a plugin for Eclipse that allows you to basically do everything you need to program from Eclipse. So you don't need to go to the command line and run some obscure ant commands, because that's what it runs off of, is ant. It's like make, if you're not familiar with it. So you would want to use Eclipse. And it's really nice, actually. I mean, you get a nice GUI emulator. It's a QEMU emulator, but a nice emulator of your device. You can run multiple devices at once. You can have, I don't think there's a limit on the number of images you can have other than hard drive space, but tons of things like that. The Android NDK and Git. Git is a, they don't like it when you call it it's a file store, basically. They have different terms they use for it. Basically, it just backs up your files. You're probably familiar with it if you're not. It's really nice. But the Android NDK, that's the native development kit. That allows you to, instead of programming in Java, you can actually program in C and most of C++. And there's a huge asterisk next to that, most of. I have no idea where they're at right now. Last summer, let's see. Yeah, last spring when I was doing my senior dissertation, they were only able to really do basic objects. Apparently they're up to almost temporalization, or they have temporalization working. I'm not sure. But basically C. But you can write C code that runs in a subsection of the Dalvik virtual machine and allows you to do the things that you're used to doing on the C-level ARM or whatever device you're doing. But here's the thing. Every device, if it has a different architecture, you're going to have to give a different package or run the code, put the code in all together and decide which one to run at one time.
So it's a trade-off between greater speed but less ability.
Not even. It's not faster. Always. You would think it'd be a lot faster because Java is slow. Well, this isn't Java. Yes, you're using Java to make the bytecode that is then recompiled and optimized for Dalvik. And that's a really good compiler. So, plus this switching from register or to register from the Java stack. My senior research was I compared function calls and looping in both native ARM, I want to say ARM 7. I'm not sure offhand right now, but ARM versus the Dalvik code. Looping was actually faster in the Java code, which might not, it might not make sense. It was like 10% faster, and that was with, I want to say optimizations turned off on both. So it was actually running through the loops and doing things and decrementing and whatnot. So it's kind of counterintuitive, but that's just the way it is, because when it's running the native code, it has to do a bunch of things to make sure the native code doesn't escape the sandbox. So you don't always want to use your native code. It's not actually going to be faster, and it's not as secure from multiple points. You don't have array bounds checking. You don't have things like that Java provides for you. So the main key of using native is, one, you have to. So you're doing something really low level, you're interacting with some hardware or something like that, or you're using a library. So you have a game engine, and you write your game engine in C, it does all these things for you, and it does low level like OpenGL or things like that. That's where you'll see the benefit from a developer standpoint is, I don't have to do any of this. It's already done. I don't care how it works, it just works. And then around that C, they wrap Java that actually calls the C, and so you just call the Java. This is, without a doubt, probably the best book for Android. If you're curious at all or interested, it's about 30 bucks. The author is Rito Meyer. He is the evangelist for Android at Google. And this book covers everything from how to install Android up to how to make a Maps application that pulls from Google Maps and can get your current location off of GPS, see you, make markers on the map, draw it, save it, and send it to somebody else. So lots of steps in there in between. But it's a really good resource for how to think Android, because the biggest issue with Android is understanding how to think the way they designed it. They designed it so modularity, everything's changeable. You don't like their telephone application? Install your own or write your own and swap it out, delete theirs, if you can. That's,
Is there a way for an app to ask, is there something set up to handle such and such, so they can say, okay, this approach is available, I'll use that, otherwise I'll fall back to this other.
That's an operating system functionality? No. So the application, well, let me.
Can you repeat the question?
Yeah.
Sorry.
How do you want? I'll repeat it. How do you want to phrase that again?
Can an app ask, is there something set up to handle this particular type of request? You know, so that if there's not something set up to handle that type of request, it can fall back to another type of.
So his question is, can you make an application that asks, I have a request A, and is there something that can handle request A? If not, I have request B. That's actually not needed because you would make a request AB. That's the URI intent functionality is that complex to where you can have, I wouldn't say a union, but a
Almost logic built in.
Yeah, there's a sorting and there's a filtering system. So you would actually just say, can something handle my SMS request? And then that's it. If something can handle it, something handles it. If not, I think you get an error, but I think you can handle it. So you can, I think you could try a try-catch block. I'm not sure. But basically, you'll know what the built-in functionality is. There's a huge list of what, like send an SMS or start a phone conversation or whatever. And then you just say, I want to do this. And if you want to make your own custom application, so might be a good example. So you want to war drive with your tablet or something. You walk around and it captures all the packets and stores them in a content provider. In the content provider, you have basically a URI filter set saying, I can handle requests asking me for content from WarDriver. And then another third-party application, if it knows how your content URI is set up, can ask for that. So you don't have to know who's asking for your data. You just have to put it in a nice, accessible format. So you wouldn't really need the fallback query. If you know what the query is, you know what it is. That's kind of one of the issues. Any question?
Yes, along those same kind of lines, I know if you have several applications that handle two different things, they'll ask you and say, don't ever ask me again. It's kind of like, almost like a file associations
Yeah, sorry.
setup. What happens to me in some cases with the browser, if I'm downloading a file extension or something that I guess it's a file extension or I'm downloading a file from using the browser,
Yeah.
you get that error that says, I don't know how to handle this, and it just drops it. Is there, do you know what I would look for?
A better browser.
Okay, so just use a different browser that would say, I don't care what you're downloading, just save it to the SD card.
Possibly, yeah.
and
There's Dolphin, which there's a free and a paid version. That's really popular.
Right.
There's, I believe, Firefox is about to be released.
So it's the browser that handles the
Yeah,
file
I'm pretty sure
association
that's the
portion of it.
browser's issue because I've stored SQL databases on my SD card, basically literally ripping them out of the internals from Android
Right.
and saying, well, here, dumping them.
Yeah.
So I've stored torrent files for the Ubuntu image on my SD card. I downloaded a ton of different extensions, and I've never had an issue like that. That's not inherent in the file system. So it's probably the browser just saying, is it the default browser?
Yeah.
It's
browser.
probably just trying to protect you because it doesn't realize what the extension is. And for most people, that's probably a good behavior, but this room isn't most people. So you might want to look under the menu config and actually see if there's an option for that too.
Everything you download has to have an application to handle this. So there is an app called Download Everything that will allow everything to download. It gives you like an application to handle it.
So-
really close to like
Close. Yeah, so the guy here was just saying that you need to have an application to handle everything. I haven't run into that. It's possible. I'll take his word for it for right now. But yeah, that does make sense. I'm trying to think of why.
I didn't have, you don't have trouble downloading most kinds of files, but there are a couple that.
Yeah, it's probably those ones that you would download on Windows, and Windows would just be like, I have no idea what this is. Windows just lets you download it, and there's an extension which isn't visible by default. Why? So familypicture.jpeg.exe. Great idea.
You wanna repeat the answer though? So there's an application out there.
Is there an application out there?
Yeah, don't download everything.
Okay, download everything. It basically just says star. I handle everything. And
And when you click download, it brings up a thing. It's what do you want to handle this download with, or what do you want to handle this application with? You hit download everything, and it just goes to your SD card.
yeah, there's a bunch of little workarounds. The download, I've heard of that application, so I've looked at that issue, but I forgot about it. There's others that are like that, but yeah, I would look into that. Question?
Is it possible to talk to low-level devices in the phone? I'd like to see an application that could talk to the radio chip and say how many retransmissions have happened in the last second for the reason of being RF noise.
Yeah. I'm working in a lab where we would love that functionality. And there is at least 10 people, professional software developers that have been working for a long time, at least a year on this project. And we don't have that. So it might be possible. I don't think it's easy. I think if it is possible, it'd have to be the native stuff. And here's the problem with ARM. ARM does not have a BIOS, standard BIOS. So every device has its own way of booting. So that's why it takes a while to get ROMs for devices. So if you ever wondered, well, why have this? Why can't I have Android on my new device? Well, they need to figure out how to boot the thing first. And device drivers are the same way. Every device driver is different, and that's a really big pain. So, trying to think, the new Virgin Mobile phone just came out, the Triumph. It's a really, for $300, it's a really nice Android phone. 4.3 screen, it's a single core instead of a dual core, but it runs almost as fast as a dual core or something. And the Cyan O Gen Mod, people were like, yeah, we'd be interested in that. It's going to take a while. That's why. Whenever a new device comes out, unless they get a device early, which Samsung's actually doing, they actually hired one of the main ROM developers from Cyan Gen 1. He's on their payroll, and even before that, they were sending him phones like a month or two before they launched. That way, when they launched, the Samsung phones could have the Cyan model.
So far we've seen pretty much everything from the VM level up with developing. In the Android platform, is there a standard environment available below the VM, say GCC or?
Oh yeah, the Android NDK, the native development kit. You don't want to use it unless you have to.
From what you had said earlier, you made it sound as if that does actually run inside a VM.
Technically yes, and technically no. So yes, think of the C code as this little tiny droplet, and around it, there on 3 edges, there is a Java wrapper, and on around 3 edges, there is the Android Dalvik virtual machine. So Dalvik prevents it from talking to other things until it gets to the Linux kernel. Then Linux security kicks in and says, die if you try to access anything you're not. Because there's a really, really nice feature that kind of makes sense, but I've never seen it anywhere else. Every process, every application that's installed has its own user ID and username, or group, user and group set. So by default, nothing can talk to anything else, which is amazingly simple, but really kind of almost revolutionary in and of itself. So no application can talk to any other application. No application can look in the directory of any other application. The only way you can do that is through IPC, inter-process communication. And the only way you can do that is through intents, or you're the Dalvik virtual machine itself. Any other questions, comments, concerns? Let's see. We have about 15 minutes, so if you just want to come up and ask your question in person, that's fine, or we can go from there. I think that's it then.